Hello, everybody, and welcome to Catholic Apologetics International. I'm here with Robert Sungenis, and I'm also here with our guest, Adam R. Rakowski, and he is a colleague of ours at the Kolbe Center for the Study of Creation. You can visit them at kolbecenter.org. And also, today we're going to be talking about the flat Earth and the flat Earth fallacy and the creation. Sorry, I've got a technical issue. Sorry, hang on just a second. Okay, we're going to be talking about the flat Earth fallacy, and we're also going to be talking about evolution and evidences against the evolutionary theory and evidence for the young Earth creation. And we're also going to get into some geocentric cosmology and just some general questions. So without further ado, we'll get into it. And what I wanted to do was give Adamar a second to introduce himself to the audience real quick, and then we'll jump right into the conversation.
Well, Pax Christi, everyone, peace of Christ. Just to put it simply, I am the 62-year-old kid of World War II refugees, grew up in Philadelphia, PA, in a large Ukrainian enclave. So I grew up bicultural, bilingual, and by ritual, Ukrainian Catholic, but also Roman. And that taught me, having to juggle all that in my mind and my soul, taught me how to think outside the box, question narratives, build a data set, and have an appropriate paradigm when I encounter something, when I encounter a data set. So it's basically that. And also the second thing to mention out of the two would be that I am not a convert. I am not a revert. I actually grew up in a thoroughly old world Catholic culture in Philadelphia, pre-Vatican II. Basically, I am the modern analog. I consider myself the modern analog of a medieval peasant. So I have a very strong sensus Catholicus, and that's how I operate. The intellect, my degrees and everything are basically tools that I use, but they're not my core, not my identity. And I think, should I mention my degrees too?
Yeah. If you want to just mention your certifications and a little bit of your experience, if you'd like, that's fine.
Okay. I have a bachelor's in geology, bachelor's in physics, LaSalle University, Philadelphia, PA, both of them. Master's in meteorology from McGill University in Montreal, Quebec, and then a sacred theology bachelor's and a sacred theology licentiate from the Pontifical Faculty of the Immaculate Conception in Washington, D.C., also known as the Dominican House of Studies. And by trade, I am a teacher, primarily high school level, though I've done everything from kindergarten to university. But the high school level is where I'm the most comfortable. And that's basically the level at which I try to talk to people, because most laymen, especially the topics we're going to be covering today, a lot of laymen probably would not know what I'm talking about unless I kept it at that level. And I think that's everything.
Well, excellent. Yeah, and thank you for sharing that. And that's especially important for our audience, just so they kind of know where you're coming from and the background that you come from as well. So what I'm going to start with is my very first question is, where did the flat Earth theory come from? And after that, kind of also, what does it mean that we're living under the firmament? And Robert, if you want to go ahead and start, and then we can just kind of, let you and Adamar shoot back and forth and talk about it.
Sure. You can go back as far as Cosmo Indicopleustes around the 6th century was probably the first established flat earther prior to some of the Greeks. We focus on him because he was a merchant of sorts, traveled around the world, and was a cartologist, not a cardiologist, a cartologist, because he made maps. And when he made maps, he made it of a flat earth. And he was pretty adamant that the Earth was flat, so he stood out at his time. And prior to him, there were various fathers of the church that had suggested, not dogmatically, but had suggested through some of their writings that if they were interpreted in a very loose way, someone could say, oh, yeah, well, this father was a flat earther. One of those was Chrysostom, as a matter of fact, because he talked about a hemispherical sky, which implies that if it's hemispherical and not spherical, but he didn't say that. He just said it was hemispherical. And that implies that what is holding it on the bottom, the foundation, is flat. Okay. If it's spherical, of course, you're not going to have the flat foundation. And that makes all the difference in the world. But some people, accuse him of being a flat earther for that reason. There was another one, another father, Lactantius, and you sort of get the same implication that he was a flat earther, because he theologically was against what they call the antipodes. The antipodes, anti means against or the opposite, and podes refers to feet. And so he didn't like the idea that men would be on the opposite side of the flat earth and basically would be standing upside down. Okay, because their feet would be on the flat earth and then their heads would be down if they were on the opposite side of the flat earth. I mean, he could see it if they were standing upright. And the verse that he would use in scripture is God made man upright. And so if you take that physically, that means his head is up and his feet are down, and his feet are resting on the flat earth. So from that idea, people impose upon him that, well, he must have been a flat earther because he's talking about these antipodes, and he doesn't want antipodes to be upside down. So you get that. But there's no direct statement from Lactantius that he is a flat earther. Like he just said, I believe in the flat earth. He's just against the antipodes. Okay. And then you have people toying with Augustine. And I forget the name of the scholar, but he wrote his dissertation on this. It's in my book, Flat Earth, Flat Wrong, which I wrote, 7 years ago. So his name is not coming to me right quickly here. But anyway, they go into Augustine and they pick out verses from Augustine that they think are referring to a flat earth. And I went through all of those passages. I went through his whole dissertation. And I didn't see one passage where you could say 100%, yes, Augustine is a flat earther. Okay. But I did see plenty of passages in Augustine where he says the earth is spherical. Okay. But see, with Augustine, you get a lot of ideas because he wrote a lot over a good stretch. And sometimes he was emphasizing one thing, and the other time he's emphasizing another thing. And so the times where he seems to be emphasizing the earth being flat, people jump on those, just like they do with other things that Augustine has said.
I've noticed that with St. Basil as well, that they do the same with Basil the Great.
Yeah. Basil's a little bit more consistent in his science than Augustine is. He's much more of he's probably the best scientist of the fathers, of all of them. Basil is. You can always depend on him to be very straightforward, very scientific. And I just admire the man so much. Now, he's an Eastern father, and a lot of the Eastern fathers are the same way as Basil. I think he led the way for them. Gregory of Nazianzus, Gregory of Nyssa, Athanasius. They're all pretty straightforward with their science, and you can understand them very well. And those fathers, by the way, all the Eastern fathers, I can't think of one Eastern father that's even hinting at flat Earth. All the Eastern fathers were definitely spherical Earth. You just have some of these Latin fathers that, it seems like they might have been partial to flat Earth. But when you really examine their writings, there's only about 4 of them that have that question. And when you go into and really see, okay, let's flip the coin, which side are they on? It always comes out to the spherical Earth side. So I can safely say that Lactantius being the only one you could say, okay, because of the antipodes, you might give room for the flat Earth theory. Cosmos Indicopleustes was the only one that was a full-fledged flat earther. Now, and who's the guy? The famous evolutionist from Harvard, Gould. Stephen Jay Gould.
Mm-hmm. Yeah.
Stephen Jay Gould came out, probably maybe 30 years ago, and he said all this talk about the fathers and the medievals being flat earthers, he says, is absolutely wrong. And he was one of the first ones in the modern day to just set the record straight, because everybody was blaming the Catholic Church medieval period, being flat earthers. And we've come a long way since the flat earthers of the Catholics, now we believe the earth is round and blah, 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 blah. And Gould says that's just a bunch of bunk. Nobody back in those days, except Cosmos, as I said, was pushing flat earth theory. So, I mean, here you got one of the most famous scientists of his day, Stephen Gould, setting the record straight for us. So we didn't really have to do that much homework on it, except when you come to like the 1800s, when you got a guy, who's the guy, Rowbotham, who did some experiments in England in that famous waterway there. I forget the name of it. Anyway, he put poles in that waterway, and the poles did not seem to.
I'm on the phone now.
Did not seem to show a curve. If you looked at them from a distance, and he made the poles, I forget how far apart they were, but if the Earth is curved, those poles should be showing a curve, at least some kind of curve. And they didn't show a curve, at least nothing great enough for Rowbotham to say, the Earth is flat. I'm sorry, the Earth is curved. So that's like in the late 1800s. And so you get a lot of people following him. But all the discussion prior to Rowbotham was the Earth is spherical. Everybody was agreeing with that. They couldn't prove it a lot because they weren't very sophisticated. There was one Greek, was it Archimedes who did it? He put his own poles in the Middle East, and he used shadows, and this proved to him that the Earth was spherical. That's a long time ago. What was that, 3rd century BC or so? Everybody had their mathematical proof that the Earth was spherical, except sometimes when they did experiments, it didn't show the Earth was spherical. And you even have that today, because, and I'm sorry to go so long on this, but I have to cover the whole history, so to speak. Today, what's this, Joshua Nowicki is the guy's name. He's a photographer. And every spring he goes to the eastern shore of Michigan and takes pictures of the Chicago skyline that's 60 miles across Lake Michigan. And sometimes he sees the skyline of Chicago, which, if you have 60 miles of distance, the Chicago skyline should be 900 feet below the horizon, right? And yet he sees the Chicago skyline, sometimes crystal
Well,
clear.
I'd like to address that when my turn comes.
Yeah, sure.
So
So, all the flat earthers, of course, will glom onto Joshua Nowicki's photographs, and they'll even get the meteorologist of Chicago in on it, and the flat earthers will say, here's evidence that the earth is flat because we shouldn't be seeing the skyline. And he's coming up with the normal explanations, like it's a mirage, it's because of this or that. There's like 4 different categories of atmospheric effects that occur that can make the skyline of Chicago appear above the horizon. Well, the simple one is, of course, that during April and May, you got a very distinct temperature change between the water and the air. And the air is much colder. I'm sorry. The water is much colder because it doesn't change its temperature as fast as the air does. And so the air is going to be warmer. And if it's warmer, it's going to bend the light waves so that the waves are not going to go straight across Lake Michigan. They're going to curve. They're going to go like this, the light waves. So you're on the shore of Lake Michigan on the eastern shore, and you're looking at the light waves, and the light waves are curved, and it's like focusing on the skyline of Chicago, and that's why they appear above the horizon.
It's wild.
And so there's a very simple scientific explanation for it, but a lot of these flat earthers, you can't reason with them sometimes. They are adamant that the earth is flat because they have other things going on than the science and the history. They think NASA is the boogeyman that's creating all these things, make it appear as if the earth is spherical. So anyway, Adam, why don't you take it over from there?
Yeah.
Okay, well, you already explained my thing about Chicago. So yeah, it's refraction based on a temperature inversion and stuff like that. So that I'm not going to dwell on that.
While you guys are going, I'm going to change my son real quick.
Okay. Yeah, the 2 empirical things I would say regarding that the Earth is actually round. First one is that I've flown a lot. I like window seats on planes. You look out the window, you can see that the horizon does have a curvature to it. So it's not, definitely the Earth is not flat. It was really obvious when I was flying from Columbus to Philadelphia one year, and you could see all the way to the bottom of Chesapeake Bay, but then everything, we were flying over Harrisburg, 3 Mile Island area. But then, the Earth dropped off at that point. So obviously, if it were flat, I should be able to see all the way to Savannah. Or even Cape Hatteras, but I didn't see further than the Virginia Capes, if that. So that's one observation. The second one requires a little bit of effort, but it's not that hard. If you're on the Amazon in the rainforest and you look north, the pole star is right on the horizon, and the Little Dipper goes around like a half circle around it. Now, if you hike, so if the Earth were flat, okay, you could say, yeah, it rotates around. But if you take a hike up to the Midwest where I live, you see the pole star about 40 degrees above the northern horizon. Now, if the Earth were flat, the pole star should still be down on the horizon because I'm walking along a flat surface. So obviously, I am not walking along a flat surface because the pole star is up, and I can see the Little Dipper going around all night, especially when the nights are long, except we have 9-hour days up here in the wintertime. So most of the night, I should be able to see the Little Dipper going around in the 3/4 of a circle, roughly, or 2/3 of a circle. So if the Earth were flat, all the constellations would be the same overhead, and I should be able to see the pole star on the horizon, even in Alaska, but that's not the case. You go up to Alaska, the pole star is very high up, and so there are constellations there that you see year-round, just floating around in the sky. They're just in different positions based on the season. So I would argue those two reasons. Flying in an airplane shows you empirically. I'm big on observation. It's curved. because I've seen it myself, and also I've seen landscapes that I know disappearing below the horizons. Like Levi, you just came back flying from Columbus to Philadelphia one year. I could see flying over Harrisburg at the Susquehanna River. I could see the Chesapeake Bay almost to the Virginia Capes, but
Wow.
then I couldn't see anything beyond that. If the Earth were flat, I should have been able to see Cape Hatteras. It was a crystal clear day, and maybe even a really, really faded because of haze, maybe Savannah, Georgia, further down. But I didn't see that. So obviously there is a curvature there because the thing disappears. So I would say that those are the two, I'd say, observational things that would indicate that the Earth is not flat. And I would put in a 2A there. If the stars and everything in the sun rotate, they do a big semicircle in the sky. What do they do at night? Do they just kind of like go like a conveyor belt and go horizontally across under the surface of the land and then come up and do their hemisphere again? Or is there some kind of hemisphere with nothing between it and the bottom side of the flat Earth? I mean, that just, you would really have to do some major imagining to figure out what these things do when they disappear below the horizon.
The sun in the flat Earth scheme is just going on the perimeter of the disk. It's following the disk. And since they believe that the sun is a cone light, not a dispersing light that goes everywhere, it's just a cone of light. The cone from the sun is going to be on the disk where the sun is. So if the cone is on the eastern side of the cone, then the western side is going to be dark, you see, because the cone of the light's not reaching the western side. That's how they explain it. It's not going to work.
I was going to say, how are they going to get that cone all the way to the other side? I mean, you're talking 180 degrees.
The sun is moving along the perimeter of the disk. So it's moving from the eastern side.
Oh, I see. That's
yeah. Let me talk about the constellations that I think you mentioned those. The constellations, I mean, in the spherical frame, we have the Polaris as the North Star. At least for now, we do. And then Lactantius would be the closest to the southern pole star if you're looking, say, from Antarctica. And so you have all the constellations that are stemming out from Lactantius as the pole star of the south, and there's a lot of them, and we never see them in the north because they're way below the equator. So we're never going to see them in the north, and the people in the south are never going to see, the Big Dipper and all those other, the Dipper you said was going around Polaris, the things you were looking at.
Yeah, the Little Dipper.
Yeah. So what has to happen if you have a flat Earth? You have to have all the southern constellations, hundreds of them, that have to fit now above the flat Earth and between the northern constellations.
Yeah.
Tell me how that's going to happen. And I've asked, who was the guy? Mark, famous flat earther. Oh, I forget his name. He made a couple of movies on this. And I said, Mark, come on, tell me, how's that logically going to happen? He goes, it's all illusion. It's all, they've made these constellations. They've made these stars. He's blaming it all on NASA for making it look like, a flat Earth when it really is. That was his only explanation.
Did you guys see the CGI video, did you guys see the new videos from SpaceX that the flat earthers are just swearing up and down their CGI as usual? That's like their main argument.
That's all they have left.
CGI is
all they have left. Yeah. And they've done the same thing, of course, when the satellites take pictures at 500 miles above the Earth. They take pictures of the Earth because they want to map out the Earth. So what's going to happen if your satellite camera is that close to the Earth's surface, 500 miles, it's like the ISS. That's only about 500 miles up. So what you're going to get is you're not going to get an expansive view of the Earth. You're only going to get sections of the Earth because the camera is not very high.
You just get peels.
You get peels. Yeah.
Yeah.
And so what you have to do is you have to make the satellite go around the Earth 100 times. And what you're going to get is 100 peels. And then you have to put all the peels together. And if you know anything about peels, they don't fit together very well. You've got to do some cutting and rearranging in order to get the peels to connect to make a sphere. And then they say, oh, well, so you're manipulating the evidence. You're manipulating the peels to make it look like a sphere. Well, in one sense, yeah, you are, because you have to, but it doesn't mean that you're trying to promote a sphere, because there is no sphere. You just have to use the geometry the way it comes to you. So, but did you guys hear about this trip to Australia? I'm not sorry, Australia, to Antarctica. Yeah. What is it, about 4 months ago now?
Had 40,000 people watching live.
Yeah.
Wait, what was that? I missed that. What happened?
Okay. So I was on, what show was I? Tim Pool's show. And we were talking about it. It was going to take place in 2 weeks. When was that I was on that show?
That was in November, I believe, last
November. Okay. So they were going to go sometime in November then. And it was a team of about 24 people or so, some flat earthers, others not so, some scientists, some news reporters, blah, blah, blah. Whole conglomeration of people went to Antarctica, paid for by some rich guy. Everybody's plane fare. And one of the guys that was on the show with me, who was a flat earther, Winsett, yeah. He was going also. And they went down there. And another guy who went was Robbie. He put on the conference in Colorado for the flat earthers in 2018 or 19, one or the other. So he's a big deal in the whole flat earther realm. And then there was another guy. I'll remember his name in a minute. So there's 3 guys that I knew that went down there, and all 3 of them came back and said the Earth isn't flat, because they saw the sun going around and not dipping into the horizon. And if that's the case, then the Earth can't be flat. It has to be spherical. And they all came back and they all contacted me and said, I'm no longer a flat earther. And these were like arch enemies intellectually, but they were good guys. They were good friends. And I said, well, I don't want to say I told you so, but I told you so. And they said, okay, so we're on a move now where we're going to promote the spherical Earth. We want your help, and blah, 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 blah. And so that's what they're doing now. And, so it's over. It's really over. And it's just trying to get everybody to the party now. But they don't want to come to the party because, they've been living in this dream world of theirs for so long and thinking NASA's the boogeyman that makes all these things appear as if the Earth is spherical. And they're just having a hard time admitting it.
Yeah. Yeah, and I run into that a lot. Basically all they can argue is the CGI kind of arguments, and other just completely outlandish kind of.
Yeah. Well, they breed on the stuff that NASA does give them.
I'm on the phone
that suggests that they're using CGI, and that is the Earth shot. Do you ever see the Earth shot where it's supposed to be taken from? The camera's supposed to be halfway between the Earth and the Moon, and the camera's looking at Earth, and it's showing Earth in a full phase, and I think it's called Earth shot. But when you look at the photograph, and you turn up the hues so that you can get the distinctions in colors, what happens is you see a square blot with an Earth picture inside of the square on top of this screen, which means that somebody manufactured that picture. They manufactured an Earth as if it was being photographed from between the Earth and the Moon. And when you bring up the hues, you can see the square. So somebody put it there. And that's what NASA did. And so the flat earthers would look at that and say, look at what they did. It's obvious what they did. They superimposed this square picture on top of this, blue screen. And so how can you trust NASA after that?
They did it to themselves. Majorly.
Yeah. And I have a picture.
I think I lost the thread here. So what did NASA do to themselves?
Well, they gave evidence to the flat earthers that they do use CGI illegitimately. It's one thing to use CGI when you want to make the peels of your pictures of the Earth come together. Okay, that's legitimate use. But when you superimpose a photo of the Earth, and they can paint these things, I met a guy at the conference who says, look, I paint these things for NASA. I paint Earth pictures. And you know how the best artists, they can make it look like it's real with paint. Yeah. And he says, that's what I do for a living for NASA. I go, oh, okay. So that answers the question of how you can superimpose a picture of the Earth, okay, that you got from your peels, all the peels that you put together. You can understand where it comes from. But you superimposed it and you made it look like somebody was taking a shot from the moon of the Earth. And that wasn't real, So they stuck their foot in the mud themselves. And the flat earthers, of course, can't make the proper distinctions. So, they're going to think that's evidence of a flat Earth. Yeah. Or not evidence of a flat Earth, evidence of the fact that NASA uses CGI to make their pictures. That's right. What I'm saying. Yeah.
You have anything you want to add, Adamar?
Well, regarding the flat Earth, I mean, that's not really, that issue is not really my bailiwick, and so I just provided essentially just a simple ordinary guy's somebody with an OG degree, ordinary guy degree, right, who walks from Brazil to Alaska and sees the constellations increasingly rotating around the pole star further and further up, which should not happen if you're walking along a giant dinner plate. Everything should be in the same position. So, I mean, for me, that would be like, okay, I'm walking on the spherical surface. And then the airplane. I mean, you're up at 30,000 feet. It's very obvious that the Earth is circular. There's a circular shape to the horizon. It's a curvature there. You don't see most of the curve, but it's a noticeable curve. It's there, unless you're flying like amid clouds or something. But if it's a clear day, it's really obvious. So.
Yeah, and the other thing that flat earthers complained about is that a pilot does not have to keep putting the nose of the plane down in order to match the curvature of the Earth. Yeah, that's correct. He doesn't have to put the nose of his plane down because the plane does it automatically. They have these things built into planes. I forget what they call them. And they're very simple devices, but they use a gyroscope and a level, and the plane then knows that it has to incrementally put the nose of the plane down to keep pace with the curvature of the Earth. So the pilot doesn't have to do it himself. They're already built into the plane.
Yeah.
Well, also the altimeter probably would tell the plane, you got to keep a constant altitude above the landscape. I mean, vary a couple of thousand feet if you're flying over the mountains, but I mean, the altimeter will tell the computer on the plane, okay, maintain, 30,000 feet above mean sea level or whatever, but don't go any closer. Until the pilot tells you otherwise. What I'm saying is,
it doesn't have to tell them because it's done automatically for them. I mean, can you imagine if the pilot had to adjust the altimeter to keep it level, every 5 seconds? Because the curvature of the Earth. I mean, the thing's going 500 miles an hour. Okay, that's pretty fast. So you'd have to make a lot of adjustments. So anyway.
Yeah. Well, all right. Well, I think we covered the flat Earth pretty darn well, and
yeah,
I think that's enough for our audience to chew on that. But Thank you, guys. And now let's get into some geocentric cosmology. Let's have some questions about that. First, and these are questions that we got from the Restore Truth conference that I hoarded and felt like this was probably a great opportunity to be able to answer some of those questions. And obviously, it's what the people want to know. So if the Earth doesn't move, guys, how are satellites in geosynchronous orbit explained? There would be, this is what the person says, there would be no such thing and thus no GPS, etc.
Yeah, well, that's a fallacy because they don't understand the geocentric system, basically. Okay. So let me explain to the audience what a geosynchronous satellite is and what a geostationary satellite is.
Yes.
So both of them work off the fact that if you send a satellite out 22,242 miles above the Earth, it's not going to have the same kind of needs that like a satellite like the ISS needs to go very fast around the Earth, because the ISS is 500 miles up. So it's going to have a great gravity pull from the Earth. So it's going to have to go pretty fast to keep that orbit. Okay. But if you're up at 22,000 miles, then the pull of gravity is not as great. And so you're going to have different things happen at that altitude. And so there's two satellites that do this. One is the geostationary satellite, and that goes directly above the equator. It does not deviate from the equator. So when it goes around, or let's say stays still, because there's two ways to look at it, it's going to be right above the equator. Okay. And those are usually our weather satellites. If you ever seen on the news, sometimes they show you maps of the whole Earth. Well, that's because that satellite's way out there and it can take those pictures, you see. So, and then you have what they call geosynchronous satellites, and they also go on the equator, but they go above and below the equator, like in a sine wave. Okay. So you can say they're geo in the sense that they're going to stay one spot above the Earth, but as they do, they're going to go up and down the equator just a little bit. And you can make them go any way you want. You can make them make a big loop like this, and a lot of radio stations, satellite radio stations, do that because they want the satellite to stay at a certain place for a longer period of time, let's say 5-6 hours, so they get the maximum reception, you see. And then it'll go down and they won't get as great reception. But you can manipulate these satellites to do anything you basically want in the sky, depending on how fast you move them and where you put them. So anyway, that's the way satellites work. So there is this phenomenon about geostationary satellites that they will be in one place above the Earth and remain there. Okay. So let's say we put it above Ecuador, the geostationary satellite. It's going to stay above Ecuador. It's not going to move. So in the heliocentric system where the Earth rotates, what has to happen? Well, what has to happen is that Earth is rotating at 1,040 miles per hour at the surface, which means that the place where the satellite is, that space is going 7,000 miles per hour to keep up with the spot on the Earth at Ecuador that is moving at 1,040 miles per hour. Okay, you understand the difference? Okay, so the further you are away from the Earth, the faster that satellite has to travel to stay at one spot above the Earth.
It's got a bigger circle to cover. Basically, to explain it to the audience, it's got a bigger circle to cover, so it has to cover more distance on the bigger circle in the same amount of time that Ecuador does on a shorter distance being around on the Earth.
Yeah. So in the heliocentric system, it's not stationary. That satellite's moving 7,000 miles per hour. And so they have to give, when they send that satellite up, they have to give it enough thrust that it starts to go 7,000 miles per hour, and its own inertia at that level is going to keep it at 7,000 miles per hour. And if it deviates from 7,000 miles per hour because of some other phenomenon occurring at that altitude, they have to rethrust it to make sure it stays at 7,000 miles per hour. Okay. So that's what makes it look like it's stationary above the Earth, because it's actually moving with the heliocentric rotation of the Earth. So now you have the geocentric model. Okay. So in the geocentric model, the Earth isn't rotating. The Earth is fixed. Okay.
I'm on the phone now.
But you still have this satellite up there, the geostationary satellite above Ecuador. It's 22,000 miles above Ecuador, and it's not moving either. Okay? It's not moving. It's staying. From the Earth's perspective, it's at 0 miles per hour. Okay? All right. So how do you explain that from the geostationary framework? Well, here's the thing. In the geostationary framework, the universe is moving east to west at, guess what? 7,000 miles per hour at an altitude of 22,242 miles above the Earth. Okay. And in the geocentric universe that is rotating that fast, and it would have to, because it has to match the sidereal rate. Okay. If it's moving that fast, what else is moving with it? Well, all the forces that are generated by a rotating universe are going to be moving with it. And we know what they are. They're the inertial forces.
Yes.
They're the centrifugal force, the Coriolis force, and the Euler force. All three of them are moving with the rotating universe. And they are just as strong as gravity, sometimes even stronger. Okay, so that satellite then has to move through those inertial forces. And if that satellite doesn't have any thrust to go the opposite direction, those inertial forces are going to carry that satellite all the way around the Earth, just like the universe carries everything else.
Right.
It carries everything else. Don't we see it go across the Earth every day? Yeah, we see the stars. Everything goes with the universe, you see. So the only way that satellite is going to be able to stay over Ecuador continually is if it what? Has 7,000 miles per hour of thrust to make it go the other way. Okay. And in that, so it's going to be fighting the turn of the universe, and that means it's going to stay above Ecuador if it moves 7,000 miles against the universe, you see.
Yeah.
That's how we explain it. Now, there's only one more thing that needs to be understood. In the Newtonian system, where you have the Earth rotating from west to east, okay, you don't have a centrifugal force, because centrifugal force and Coriolis force are fictitious in Newtonian system.
Yes.
They're only effect. Okay. In the geocentric system, the Coriolis and the centrifugal are real forces that have to be fought with real power if you want to stay above the Earth. Okay. So that's how the geocentric system is going to answer why that satellite doesn't fall to the ground.
Yes.
Because it's standing still. Why? Because the centrifugal force is pulling it away. Because the centrifugal force in a geocentric system is a real force that goes outward, you see. Now, for the geostationary satellite, you wouldn't have the Coriolis force, because the geostationary satellite is going around the equator. It's not doing that sine wave above and below the equator. And if it did do the sine wave, then you would have a Coriolis force as well. Okay. But just for the simple geostationary satellite, all you need is the centrifugal force going in the opposite direction, which we can prove by the mathematics. It's not hard. And that answers the geostationary satellite for the geocentric system.
Yeah, well, one question for clarification. Even though I have a bachelor's in physics, the one force I never learned about was the Euler force.
Yeah.
As for the audience, EULER, what does that do? I mean, the centrifugal thrusts the thing outward, and so on, and gravity pulls inward. What does the Euler do? And the Coriolis, of course, deflects sideways, but
Yeah.
and that makes the weather system spin. But what does the Euler do?
The Oilers not really going to play a big part here because that's just the way you would understand the Euler force is if you're on a merry-go-round that's stationary, that hasn't moved yet, and then that merry-go-round starts to move. Well, that initial force you feel that's pushing you backward, that's comparable to the Euler force.
Oh, okay.
Once the merry-go-round starts and it continues, you don't feel the Euler force anymore. So it's inconsequential. So the only two forces in play are the centrifugal and the Coriolis in this realm. But the Euler can be important in other realms. Okay. It's just not in this one.
Gotcha. Well, that brings another great question that goes right along with the conversation. If a space probe was to go outside of our solar system, could it send back information and tell us whether our solar system is geocentric or heliocentric?
Adam, you want to answer that one? Because I can answer it, but
I would say because it all depends on the reference frame. Because the mathematics is the same whether the sun is the center of the solar system or the Earth, so you can't determine one way or the other. That's my ordinary guy answer to that.
Yeah, well, the ordinary guy answer is correct. I mean, and it's funny because people have a hard time seeing this.
Yes.
I had a guy, I was on a program Friday, and I had a debate with this guy about geocentrism. And what was his name? Gosh, I'm so bad with names.
You said it yesterday, and I cannot remember.
Jordan, was it Jordan somebody? Anyway, so he was asking me, and this is exactly the same question you're asking. He says, let's say you had a camera, a satellite with a camera at Lagrange point 1. Right? Lagrange points are there's 5 points outside the Earth that have like zero gravity. They're because the gravity of the sun and the moon and the Earth all converge at a point, and there's like no difference in the gravity. Okay, there's 5 of those points. So he said, let's put it at Lagrange point 1, which is one that's closer to the Earth than Lagrange point 5. And he goes, and it's taken a picture of the Earth, and over like 24 hours, and it sees the Earth rotate. And he goes, how do you explain that? And I said, look, Jordan, I think that was his name. I said, if the universe is rotating around a fixed Earth, that means it's carrying everything with it. Everything that's above the surface of the Earth, that universe is carrying with it. So it's, of course, going to carry the camera at Lagrange point 1.
Yes.
Around the Earth. And so when you take your picture of the Earth, it looks like the Earth's rotating.
I was trying to explain this to somebody too, and yeah, they have a hard time grasping this concept.
Yeah. So,
can I jump in here for a second? About 8 feet off camera, I have my elderly mother who's really ailing. Could we possibly do the questions that are geology? Jump into those in case I have to help her because she just got up from a nap and I don't know how she's going to be.
Sure. Yeah, that'll be fine.
Yeah, because I don't want to suddenly have to skip out right before my specialty comes up. So.
Okay. So, that's just fine.
Yeah, sorry about that, but I have to deal with whatever she may need. So
I understand. I got 2 kids here. That's finally calming down. But yeah. Anyways, so
and I'm the guy with 11 kids. And
I know, dude, and you're like the calmest one here. You got no interruptions. Look at you, dude.
Go ahead, Adamar. Take it away, man. Do your thing.
All right, Adamar. Here's a question for you. Does the global flood produce levels of striation in the same sea levels around the Earth?
I would need clarification on that. If I'm understanding the questioner directly, would you
Like
have
at
basically the,
I guess
like
at
the
the
same
various sea
strata
levels,
bundled?
is there different, is the striation pretty consistent, or, or is it the
Oh, yeah,
same?
yeah. Okay. No, well, you would have, they call them mega sequences. You can look these up online. There's like the SAUK, SAUK. There's about 6 or 7 of them. And basically, they're the same bundle of strata. I mean, they vary in thickness and some of the sequencing, but they're pretty much the same. And you see them globally. You'll see them in the middle of Brazil. You'll see them in Europe. You'll see them in Africa. You'll see them in North America. I mean, they're going to be crumpled in places where you have mountain ranges, but they're striking in their consistency. Like you look at the white chalk cliffs of Dover. You look at the limestone in central Texas, where I go looking for human footprints in the dinosaur age rocks. You see them in oh my goodness, other parts of the world, really, like around Egypt or whatever. You'll see pretty much the very similar sequencing in different parts of the world at the same level. Because essentially, what happened in the flood, you had the low-lying areas flooded out first, and then the material coming out of the fountains of the Great Deep would grind up the sides of the cracks, and it would deposit a particular sequence of material, and it would basically build up. You have like basically initial volcanism with the lowest areas covered. Then you would have no volcanism, no volcanic stuff, and sedimentary rock that was more less marine. And then you'd have another sequence where you would have more volcanic material in there. And then you would have yet another sequence where the water was running off, and that created a whole bunch of deposits too. But they're consistent around the world, I mean, with interruptions here and there. And the sequence, if you have the whole stack of them in certain portions, it's consistent, let's say, in the Appalachians, and then you'll find the same thing in let's say, the Great Dividing Range of Australia on the east side of the continent. They'll be very similar. Basically, they're recording the same sequence, the rough sequence of events. And the more marine ones will be deeper down. The more initial volcanic and the grinding up of continental rock would be the next. And then you'd have without fossils, and then you'd have stuff with fossils, I think, above that. And then you'd have like a cutting down type of deposit. I'm painting it with a very broad brush, but they are consistent, and they're at different levels, and that layer cake repeats itself in various continents. You don't see it in the oceans. That's the thing. That you only see them on the continents. The ocean basins are actually they have very little sediment on them. They're almost sediment free, except along the continental shelves, which only extend for 100 or 200 miles offshore. And then you have a couple of thousand miles or more of ocean with hardly anything on the bottom. So,
which
hopefully that
shouldn't be
covers
the
that
case.
purpose.
Let me just add this, which should not be the case if the Earth is millions of years old.
Right.
Why?
Exactly.
Because you continually have runoff from the mountains into the oceans. Those oceans should be at max full of sediment, where they're just popping out of the surface. Considering how long the evolutionists allow the Earth to have sediments run off. I mean, it's just ridiculous. Yeah. You only find inches at the bottom of the ocean. That means you have a young Earth. You have to have a young Earth.
That's such strong evidence, yes. All right. Now, my next question. Since flood stories have survived in other cultures, can we assume that people survived beyond the 8 in the Ark?
I would say no, because I can give you two things evidence-wise. One is an ancient Chinese pictograph for I forget whether it's for the word eight or whether it's for a boat, but basically it says eight. Oh, I think it's the old Chinese symbol for boat, where you have a vessel and the symbol for eight and the symbol for person. So eight people in the vessel. That's the ancient Chinese pictograph, I think, for a boat. I mean, you could look it up because there are basically flood references in the ancient Chinese script. But the other thing is, all you have to do, and again, this is the ordinary guy in me talking. All you have to do is look at human families. You have, let's say, a family with 10 kids. And some kids are going to get married. They're going to have exemplary lives. Their kids are going to be super educated, and they're going to know all the family history. And then you're going to have some of the 10 kids being black sheep, and they'll be living lives of like really degeneracy. And so their kids, if they have any, aren't going to have much family history at all. They're just going to get a garbled version of it. And so basically, when Noah and his family, the 8 people, came out of the ark, their descendants, depending, I would say, on the moral character and plus the physical circumstances of their descendants, determine how much of the original story got passed down. You know, if you have a father that's busy doing evil stuff, he's not going to take care to pass the truth on to his kids. He's going to be too interested in his sins. And then you'll have the conscientious fathers passing it on to their children through multiple generations. And also, this is like a game of telephone. You know, the people that are furthest away, for the most part, have the most garbled version. So you go to like, let's say, New Zealand or maybe the Western United States, you're going to have a lot of the elements of the story missing, whereas the peoples that are in the Middle East are going to have a more complete version because they didn't wander as far away, and so the information still managed to trickle down, even in spite of people being, not passing it down accurately. So I would say that's the whole that's the whole reason behind that. So yeah, so it's not that there were different people, people that survived the flood. It's just impossible. I mean, I've seen enough of the geology to see what a cataclysm it is. There'd be absolutely no survivors. Absolutely no survivors. Because it was just too thorough a destruction. I mean, there would be literally no place for anybody to survive. If you're a fish, you would survive, or if you were a waterborne mammal that could breathe through a blowhole, you stood a chance of survival. Which is why the whales were not taken on board the Ark. And of course, no fish were taken on board because you can't drown fish. So, I mean, a lot of them got killed anyway by the sediment deposits and whatnot, the violence of it. But a lot of them survived. They're still around. So, but they didn't require an Ark. It was the air breathers that went, including the human beings. So that finishes my answer.
Yeah, I could add to that is the Bible is not afraid to give small numbers as the reality of what occurred. Let's take Paul talking about the time of Elijah, wherein he says there were 7,000 who didn't bow the knee to the god Baal. And this is in the 800s BC when Elijah is the prophet. And you have between 5 million and 10 million Israelites existing at that time, if not more. So he can only find 7,000, and God's not ashamed of that number. He says, I have 7,000 who haven't bowed the knee to the devil. This is a nation of 10 million people. That's like 0.014%. Okay, but God's not ashamed of that. And then you have in the Exodus from Egypt, you have at least 600,000 men, according to Numbers 1, that came out of Egypt. And if they were married, that means you have 600,000 women. And if they had one child, you have 600,000 kids. So that's 1.8 million. And out of that 1.8 million, guess how many actually made it to the land of Canaan from that original group? 2 adults, Joshua and Caleb. And all those that were under 20 years old when they were traveling through the desert, because they were kids when they started out. That's it. And the Bible's not ashamed to say, look, we only had 2 people out of at least 1.8 million that came out of Egypt to go into the land of milk and honey, So that it shouldn't bother us that there's only 8 people out of millions of people at that time during the flood that actually survived.
It should strike fear in us, and you think looking forward ahead to the coming judgment, and Christ's parousia. I mean, we should really take very seriously the warnings of what's coming.
Yeah, if there's anything, the takeaway from that is, as I tell people on my show, don't mess with God, because he is serious about what he's saying.
Yes.
Anyway, any more questions for Adamar there?
Yeah, I got one here is this person says, being from Wisconsin, ice and glaciation play a sizable role in shaping and flattening our landscape. Do ice age periods compete or complement your Great Flood theory?
Oh, that's actually pretty simple. Using the paradigm that I taught at the conference, the hydroplate theory, at the end of the flood, you would have had very deep, warm ocean basins with a lot of warm water, and you would have had very high continents with cold temperatures. And so you'd have all this moisture evaporating to the top, falling down this torrential snow, building up ice caps, like literally within a century or two. And then that stuff would start flowing out like tar, which ice does anyway. And remember, people back then were living 500-600 years. This is a lifetime of the erstwhile age length. And so basically, there was really only one ice age. It would have expanded. It would have covered, the portions that we have that are evidence of glaciation, and that's it. And it would have retreated. As we'll see, what happened was then that because the mantle was like tar, it was like think of a waterbed filled with tar instead of or syrup instead of water. What would happen is over a century or 2 or maybe 3 centuries, the ocean floor would rise slowly. The continents would start slowly sinking, and so the continents would gradually go below the freezing level. So the ice would melt, except for the highest mountaintops, and also the ocean levels would rise because the floor is rising, and there's water running off from the ice caps that are melting. And so you would have had, right after the ice age, you would have had the period of Peleg, when the Earth was divided. That would have been the land bridges connecting, let's say, New Guinea to and Australia to Southeast Asia. You would have had the one with Alaska and Eastern Siberia. All those places, those would have all been inundated then. And in other places too. I'm just giving 2 examples here. But then that would have ended up isolating the people. But the point is, the ice age would have happened only once during the post-flood, the immediate post-flood era for several centuries, and then that would have. I would even argue that it happened around the ice age was ongoing during the building of the Tower of Babel. But that requires some elaboration. But if anybody's interested, I would explain that in detail later. But the point is that it was just one ice age, very dramatic. And if people have trouble picturing anybody in the audience of heavy snow, there's an example in Greenland where there were planes, I forget whose Air Force it was, that were abandoned on the ice sheet. And then 25 years later, a search party, nobody died there as far as I know. The planes just had to be abandoned for whatever reason, mechanical difficulties or something. But anyway, they went looking for these planes just 25 years later. I mean, we're talking not even about a generation later. They couldn't find them initially because they had them buried under, I forget, like 25 or 30 feet of snow. They were iced over totally. They had to, and plus the ice cap was, flowing. So they drifted for a distance from where they originally had landed, but they were buried deep, where they weren't visible from the air. I think they had to do ground penetrating radar to get in there and then find where they were. So you could conceivably have, if you have warm oceans, very high continents, with the very heavy snow falling out, you would have had an ice cap forming very rapidly and extensively until everything gradually settled, and which would take time. I mean, the adjustment time. So, okay, I'm done with that response.
Okay. All right. Well, Adamar, those are like the only, super specific questions just, referred to you. If you
Okay.
need to stop, that's
Well,
fine.
so far, so far, no requests. So
Okay.
I'm gonna stay on, but I just wanted to make sure those were covered before so I wouldn't have to interrupt them, to help out.
Okay. All right. Well, I guess we'll just stay on the topic of evolution and geology as well. Have either of you guys been to the Ark and Creation Museum? And if you have, what are your thoughts on that?
I went
I,
to the Creation Museum, but not the Ark.
Okay. Well,
the
then
one oh yeah, I went to the Creation Museum. Where is that? Is that Florida?
I'm not sure.
No, that's the one. That's across the river from Cincinnati.
Oh, I know I was there. I'm trying to figure out when I was there, but I haven't been to the Ark yet. No.
Okay.
They advertise it on TV every once in a while. Got two kangaroos talking about coming to the Ark.
Okay. That's funny. Well, then that'll kind of end like the more geological questioning. Let's jump into a little bit of the evolution while we still got Adamar with us. And then I want to get back into the geocentric cosmology because there's a few questions I definitely want to cover in this interview. So we'll do a couple of evolution questions real quick, and then we'll jump back into geocentric cosmology. All right.
Can I like to ask Adamar a question if you don't mind?
Man, you jump in whenever. Yes.
Okay. Adamar, are you familiar with CRI and all those Protestant outfits that deal especially with creation? You've heard of them, I'm sure.
I've heard of them. I'm not intimately familiar with them.
Oh, okay. So
I'm sorry. Go ahead.
They follow the guy that you mentioned, the hydroplate theory.
Yes.
What's his name again?
Walt Brown.
Walt Brown. Yeah. I've got his books, and they follow that hydroplate theory and their idea, their understanding of what happened was that we had a Pangea prior to the flood.
That was one of the questions I was getting ready to ask, so this is great. Thank you.
Okay. And the flood.
Actually, go ahead.
And the flood, because of the land masses breaking up to allow the water from underneath the surface to come up. And I think Walt Brown holds to this as well, that this is what caused, most of this is what caused the rain for 40 days and 40 nights. Otherwise, the atmosphere would not be able to hold 40 days and 40 days of rain. So most of the water has to come from beneath, and it shoots up miles into the earth and becomes the atmosphere, basically. And then, of course, gravity is going to pull it all down, and it's going to come down in the form of rain. But my major question here was, because you mentioned Peleg. In the days of Peleg, the earth was divided from the genealogy in Genesis 10 and 11. My understanding, as we are putting it together in the DVD series, How the World Was Made in 6 Days, is that you had a Pangea that was one basic landmass. It did have its cracks and its crevices, Pangea did, but it was basically one landmass. And that the flood is the thing that broke up that landmass. And after that, the continents separated and are still actually moving very slowly, but there's still momentum is still moving some of these continents away from each other. But that was the force of the reason for the continental drift, was the explosion that occurred to allow this water to come up and cause the flood, and the momentum forced the continental masses to drift apart. Is that your understanding?
Actually, it's more. It's a bit different than that. Basically, the Earth was one big granitic shell with an irregular bottom, so granite like tombstones, and then basalt underneath for the rest of the Earth. and the mantle and the solid core. That would have been more the darker Hawaii type, the kind you have in Hawaii. And then the granite would be like you have in the Sierra Nevada. That would have been the crust. And you would have had a layer of very hot, salty, mineral-rich water heated by the tidal flexing of the sun and the moon going around the Earth. And there was an equilibrium situation. Was that?
I said, notice he said going around the Earth.
Yeah, they're going around the Earth. I mean, an OG like me sees them going around the Earth. The Earth is not going around the sun. Yeah, I mean, it's just common sense. I mean, otherwise you may as well convince me the emperor has no clothes on, or has new clothes when he doesn't have any, or whatever the story is. But in any case, but the point is, there would have been a granitic crust. There would have been some bodies of water on it, but they would not have been connected with the 60-mile down water. And when God decided to punish the world, because it was partially a supernatural event, he allowed that pressurized water to blast out along the equivalent of a baseball seam around the Earth. And what that did is it power blasted huge areas of that crust into sediment, which is now, we got 2 miles of sediment on average on all the continents. You know, the original granite is like 2 miles down. In some places, it sticks up above the surface like the Canadian Shield, but in most areas it doesn't. And so that stuff that used to cover the Atlantic Ocean, the Indian Ocean, and so on, that all got blasted up onto the continents. And then part of that granitic surface actually collapsed on the Pacific side, because when you removed everything from the Atlantic, 60 miles of overburden, that interior of the Earth just kind of rebounded upward because there was nothing holding it down except some water. And then in the sphere, when you have a small area going up, like the relatively narrow Atlantic, the relatively wide Pacific collapsed into a million pieces, and that collapse caused extensive melting, which is why the Pacific floor is now paved with basalt instead of granite. The granite's deeper underneath. And then you have a million volcanoes there, most of which are not active, but there's still quite a few that are under the water. And when the Pacific collapsed enough and the Atlantic rebounded enough, all the water under the continents had not yet fully drained. It acted like a lubricant. And they all slid toward the Pacific Ocean mostly very rapidly. We're talking a process that took maybe a few hours, maybe a day. And then wherever they snagged on something on the bottom, because they had an irregular bottom, you had a mountain range being thrust up, which is why if you look around the Pacific Basin, you basically have they call it the Ring of Fire, but it's also a ring of mountain ranges. I mean, you're starting with the Palmer Peninsula of Antarctica, Andes Mountains, the Rockies, the Alaska Range, down to the eastern Russia, Kamchatka Peninsula, Japan, that whole area, that's the result of continents sliding toward the Pacific Basin. And also...
so basically, Adamar, let me interrupt you. So basically, the continents are like digging up this whatever dirt, soil, whatever, basalt, whatever is there. It's digging it up like a bulldozer, because it's moving outward, and then all this stuff comes over the continent and forms a mountain, basically. Or are you saying that the mountain comes up?
No, the water coming out of the cracks acted like a giant power washer. It just pulverized each side of the crack and just kept pulverizing outward and outward. Because, I mean, it was like under roughly 22,500 atmospheres pressure. And it was about close to between 7 and 1,200 degrees Fahrenheit. So this would have been red hot water, but because of the expansion, it cooled off to room temperature by the time it went into the atmosphere. But the point is, the blast of it pulverized the granite into pieces and ended up depositing it on either side.
Okay, yeah, that's exactly what I'm saying. That's exactly what I'm saying. Yeah.
But then when all that stuff was removed in the Atlantic Basin, and and a couple of other places too, but Atlantic mostly, that part of the Earth bounded upward 50-something miles, and the Pacific side fell down about maybe 7 or 8 miles because it was a much bigger area, and so the continents that were not collapsed, which would have been everything away from the Pacific, they all of a sudden had a a topographic depression on the Pacific side and a topographic high on the Atlantic side. And so those remaining big blocks of granite, still having some water underneath, acting like a lubricant, they slid sideways toward the Pacific, and some other sliding too, because there's mountain ranges also. But wherever they snagged, the sediments, which were like a layer cake, got buckled upward, and that's why you have like the Rocky Mountains. That's why you have the Alaska Range, the Andes. That's all sediment that used to be horizontal, but because the continent couldn't continue going because of friction at the bottom, the granite and all the sediment up top got crumpled up into giant mountain ranges. And also with the crumpling, you have melting. So you look at the Rockies, there's quite a few volcanoes there that they're no longer active, but you hear about the Rockies and out west, there's all this mining there. And that's because you had all these volcanoes erupting all over the place. And that magma was bringing all this metallic ore up. But the point is that the crumpling was the primary activity. And then you had also the friction producing volcanic activity here and there, actually numerous places. But but it would have been the original sediment, the original granite that was there, and the 2 mile blanket of sediment that's being thrust upward by the snagging. So and this all happened underwater. So Noah and his family were not affected by it. This was all happening underwater, and the Ark was just undulating with whatever tsunamis or anything were up there. So they didn't see it happening. It wasn't until Ararat broke up through the surface that they actually drifted onto it and started, the Ark settled down on it.
Yeah.
But all this stuff happened very startlingly rapidly.
Not over millions of years.
Oh, definitely not over millions. I wouldn't even say over a week. I mean, we're talking something that happened in a matter of hours or maybe a day.
Yeah.
Like a 24-hour period, and that's it.
Great. Yeah. Thank you so much for that.
Oh, you're welcome.
Yep.
Right.
While he's looking for the next question, would you say the friction-based idea of mountain forming is the same thing that would occur in places that are not on the Pacific or the Atlantic, but are like in Nepal with Mount Everest? You got the tallest mountain
there. Yeah, well, see, what would have happened there, that was one of the exceptional areas where the piece of granite where India is right now, that ended up being somehow I think Australia and India are in one block of granite. And for some reason, that particular C-shaped block, because it's shaped like a letter C, that rotated up toward Asia. Because if you look at the mountain ranges of Asia, you go from like roughly Afghanistan toward Vietnam. You have this giant wrinkling, like somebody pushing a tablecloth with their hand. You develop these little cloth mountain ranges on the dining room table around your hand. And that's exactly what the mountain ranges in that area look like.
Oh, wow.
So they've been thrust up because that particular block of whatever reason got rotated up that way instead of directly toward the Pacific.
So are you saying that C-shaped piece of granite is one solid piece of granite?
Yeah, I mean, the plate tectonics.
Wow. How many miles are we talking about here?
Let me see, about maybe 6,000, because Australia is a 5-hour flight. And then you have another roughly 5-hour flight from Perth to the nearest point in India. Yeah, that whole thing, because even plate tectonics people, they consider that to be the Indo-Australian plate, or at least they used to when I was in college. So that whole thing would have been one, and it would have slid up into Asia and buckled the sediments there.
Yeah.
And now the reason India doesn't have a lot of mountains is because it was further away from the collision zone. And also, when the floodwaters were running off, they would have basically scoured India mostly flat. It's got mountain ranges on its edges, and that you have to explain those yet. But yeah, and you could argue also that block primarily slid into South Asia, but then I would say that the eastern end where Australia was slid a little bit toward the Pacific, because you do have a mountain range along the eastern edge of Australia, the Great Dividing Range. So I would hypothesize, because I mean, we're doing science. I mean, we're kind of piecing the puzzle together as we go. I would say that C-shaped piece, the northern end really slammed into Asia. The Australia end only slightly went toward the Pacific. It thrust up that mountain range, but it's not very tall. I mean, 7,000 feet is the highest, Mount Kosciuszko in, I think it's New South Wales. But at the other end, I mean, you have the Himalayas. I mean, they're pushing 30,000 feet. I mean, Mount Everest is what, 28,000?
So let me ask you, this C-shaped granite, is the C open-ended on the western end, and you have the back of the C on the eastern end, and it's moving east?
Well, basically, you would have had what I think happened, and again, I'm
or maybe northeast,
hypothesizing
maybe moving northeast, because it has to hit Asia.
Well, the upper end of the sea would have been sliding northwestward or northward, actually, and the eastern end slightly eastward. I'd say the sea was primarily sliding north with a little bit of an eastern motion. That the eastern motion would have kicked up the mountains in eastern Australia, because Western Australia doesn't really have mountain ranges, hills basically. And then the northern end of that granite would have slammed really hard into South Asia. And the question is, why is it going in that direction? It may be because the Pacific Ocean collapsing to the northeast of there may have caused it to rotate violently in that direction. Or there may have been something going on in the Indian Ocean that we haven't figured out yet that caused it to go up in that direction and basically fill in a depression. It'll be interesting you mentioned antipodes earlier. I'm wondering what the antipodal point to the Himalayas is, because there may have been something rising up on that side, and then that would have created a depression right there into which this C-shaped piece of granite slid and thrust up the Himalayas. But that's something we need to investigate, because I mean, the hydroplate theory gives the broad picture, but you still have to work out the details. There's a lot of details. I mean, including I mentioned at the conference the South Sandwich Islands and the Caribbean islands. It looks from the map, especially if you turn South America sideways instead of north-south like we're used to seeing it, it looks like the thing slid down because you have all the mountains at the leading edge, but then you have these two. They look like little whirlpools. Like when you have somebody walking in the pool, you got a whirlpool on either side of their waist. That's what these things look like. So when that thing was sliding toward the Pacific, it created some kind of ripple effect that raised up these islands. I mean, the South Sandwich Islands almost nobody hears about because they're subarctic, but then everybody knows about the Caribbean ones. And you don't realize that, you look at a map with the proper projection. I mean, they're roughly the same size. The Caribbean arc is a little bit bigger than the South Sandwich, but the fact is you have that kind of rotational there. But that's something that has to be puzzled with.
That's a whole science in itself, because
yeah.
water is going to assume the volume of its container. So
Right.
if you're moving a mass of water and it's making whirlpools, that's creating a vacuum. It's got to be filled somehow in back of it,
Yeah. I mean, because we have it. And the water. Remember, you're dealing with vast quantities of it, very deep, and that water doesn't behave like your bathtub water. It's actually more violent. And there's evidence of it actually on the mountaintops of, I think it's northern Nova Scotia or western Newfoundland, where you have these mountain ranges that have solid rock up top that's just totally planed clean. Like you just have a few little boulders and cobbles and gravel there, where the frost action hasn't been around long enough to produce a lot. There's hardly any soil. And you're wondering how something could have eaten into that solid rock without leaving any soil behind or anything. But if you have a very deep sheet of water moving very rapidly, you develop what's called cavitation, which is the violence of the current will create a partial vacuum, and the water is forced to form a gas, like a bubble. And then when that bubble snaps shut, it produces a shock wave that then will break the rock underneath, and the rock will be swept away. I mean, you see that with motorboat propellers. You have to design them just right because the cavitation will dent the metal and ruin it. And also you see that in spillways from dams. where you have a flood, the spillway is perfect for the volume of water, but because of the water is turbulent, it creates cavitation, these big bubbles that collapse, and it basically shatters the concrete at the bottom of the channel, and the spillway is destroyed. I mean, the water's still running through, but it's no longer neatly doing that because the interior has been broken. And so what I'm thinking happened here, you would have had cavitation on Newfoundland mountains in Nova Scotia, but also you would have had conceivably cavitation on a very large scale in the Caribbean or in the South Sandwich Islands, which may have forced the crust from underneath to melt and create these islands, or at least start the process going. I mean, this is really a very we're only scratching the surface with the hydroplate model. We're only scratching the surface. Because,
but at least you have a rapid model that shows that this can happen. Whereas the evolutionists say they want this to go over millions of years. And how do you do that? So you stay away from this whole water idea that water is moving, and this things just happen incrementally. And that's how they think they get away with it.
Well, I mean, one big puzzle that I would give you, because I love to travel and I recommend to everybody in the audience, start requesting tourist information from all 50 states, especially not New England so much because it's basically granite, but the Western states especially. There's a ton, like we're talking 500,000 square miles roughly of level strata everywhere. Even in the Rocky Mountains, you have level strata that were then thrust up and tilted or cracked or whatever, but they were originally level. How do you produce that much level material unless there was one process that put it all down very rapidly? I mean, the big thing is, the evolutionists would say, well, the Grand Canyon, it was the Colorado River was eating downward at the same rate that the Colorado Plateau was rising, and that's not plausible because, I mean, you've got a mile layer cake of rock there, which, except for the bottom portions which are tilted and cut off, it's level. How do you deposit that much, without any undulations really of any sort, or any significant undulations? Because I mean, you look around everywhere. I mean, you have creeks or whatever, and then even where you look at places where stuff's deposited. I mean, continental shelves, they only go out for like 100 miles or 200 miles. Colorado Plateau is vast. It covers multiple states. And then these strata continue north into Montana, Wyoming, and all that. How do you do that? So there has to be one process. So I'm just getting
Let me ask you another question, Adamar. The way the creationist looks at the fossil record is that these fossils were created very rapidly. I mean, we even had some with food in their stomach, and then a fossil's created from that. Okay, in the rock, of course. So it's our whole design is based on how rapid this thing occurred. Now, if you're an evolutionist, that's anathema to you.
Right.
Yeah.
Something rapid. So explain to me how you think they explain how a fossil was formed. Because you have a strata. An animal is on the strata, it dies, it deteriorates. Something has to make an impression in the rock to make that fossil. Okay? How is that going to happen if you have all these, wind currents and rain and animals eating animals and all that? How are you going to get a fossil formed at all?
Exactly. That's the point. I mean, I'm an outdoorsman from childhood. I've seen a lot of carcasses outside. They don't last long. I mean, you get the beetles getting on them, the bacteria, the flies, scavenging like coons or whatever, possums, and they're gone. So to have graveyards of dinosaurs, graveyards of fish, graveyards of mammals, you have to have a violent event that's very rapid that buries them before they can be scavenged. And also, in some cases, buries them where the flesh is still preserved, like in the Hell Creek Formation in eastern Montana.
Okay, so this you don't have to go into detail because we both understand what we're saying. So have you rubbed shoulders with any of these evolutionists Say, oh well, this
Well, I mean, I did a bachelor's in geology back in '84, where I mean, I was an evolutionist back then myself. But Mary Schweitzer's fleshy dinosaurs weren't discovered yet, and the assumption was that they got buried, they got rotted away. The solid parts got mineralized by water running through the sediment slowly, and then it got eroded and exposed, and that was that. And but then when you assume that paradigm, it doesn't occur to you to look for other things. But one thing that really intrigued me is I had what was it? A brachiopod fossil. It's kind of like a clam with a ridged shell. And I remember it was in shale, which is petrified mud. And I remember dripping some dilute hydrochloric acid on it. That's what you use to determine if there's calcium carbonate. And the shell fizzed. And it's like, wait a minute, this thing's 500 million years old, and it's got the shell is still intact. How can this be? You have water running slowly, seeping through all this sediment. That shell should have been replaced like with silica or something. So that made me start wondering that and the stalactites I read about. Yeah, I mean, and
that would make me wonder.
The thing is, yeah, but I had no paradigm. That's the problem. I saw something was right. It wasn't right, but I couldn't explain it coherently. Yeah. I could only doubt. Yeah. But I had nothing to replace the evolution with. So I'm thinking maybe this was a fluke or whatever. But
so is that stop there for a second? Is that what these guys are going through? They only know one paradigm. They don't know about the flood creation model at all. Nobody's ever taught them that. So they're like sitting there saying, okay, my best guess is I don't know. Instead of going to the fact that this could have been a rapid thing that occurred so fast that you couldn't believe it if we told you. Is that the kind of doubt that they're in? They just don't.
It's like they refuse to even look into it.
Well, I would say there's a couple of other things there too. Fallen human nature. First off, there's the issue of pride.
Of course,
I would have to rethink of everything.
Yeah, but I'm giving them the benefit of the doubt that these are intelligent men. Okay.
Okay, and honest men. Yeah, but then the problem is if they have zero paradigm to work with, and in a sense, I mean, higher academia, has to some degree it's an echo chamber, and so outside ideas kind of don't penetrate; they're not discussed, so. You're basically operating from that.
That's what Mary Schweitzer went through. She didn't have another paradigm to go to, and Jack Horner, her boss, she told him that it looks like blood vessels and collagen and all that stuff. And you know what he said to her? I read this in the December 2010 issue of Scientific American. Do you remember what he told her?
Yep.
He goes, find a
way to make it happen.
Tell me that they aren't, he said. Those were his exact words. Tell me that they aren't.
Oh, okay. I didn't realize that part. I thought he told her figure out how you can preserve blood vessels for 65 million years.
No. No.
Hang on. I have to switch Bluetooth here in case the thing cuts off.
Robert, he really did say say that this just how they aren't blood vessels.
Tell me that they aren't, he says.
Oh my goodness. Wow.
Explain to me that they aren't. That was her quest.
Hello.
And of course she wants to keep her job. Who wants to get fired?
Wait a minute. I gotta reconnect. I have to.
He's got to reconnect.
Yeah. Just reconnect the Bluetooth. I can hear you
on
no
problem. I'll get it.
Yeah. No. It's not the program. It's my Bluetooth. My Bluetooth.
Oh, okay.
Yeah. For some reason, it's.
Yeah, Robert. I thought that was just the most revealing thing that you could find is him saying that.
No, I still can't hear you.
Yeah.
Hang on. Am I on your?
He is a perfect example of what happens in academia today.
We can hear you.
Hello?
Yeah, we can hear you.
That's weird.
I can hear you.
Just you can't hear us, I don't
Oh,
think.
I cannot hear you guys at all. Hang on, maybe. How's this? You can hear me. Say something.
Hello.
Hello, how are you?
Oh yeah.
Hello,
Okay,
how
I hear
are
you.
you?
Okay.
Okay.
Okay,
Much
we're
better?
back. Okay.
Okay, good.
Yeah, a lot better. Yeah, but anyway, the yeah, like what you're saying, Bob. I mean, if you don't have a paradigm, you have difficulty defending your doubts or progressing into them further. That's why it's important for us to
Well,
present these different
there's
paradigms.
guys like that famous a paleontologist. I think his name starts with a G. Oh gosh, what is his name? But he actually takes on the creationists. And he says, look, I'm not doing this because I'm just against creationists. I'm doing this because the science shows it. The science shows it. And yet I'd love to get him in an interview where I posed the question that I posed to you, which is, okay, you got this strata, you got an animal on it, it's deteriorating, you got to make a fossil out of it. How are you going to do that?
Yeah.
Before the next strata that's supposed to come a million years later is going to cover it and make the fossil for you. How's that going to happen? I haven't had one evolutionist explain that yet.
Or how are you going to do that with millions or thousands in the graveyard? You know, where you don't just have one single fossil, but you have herds and herds of dinosaurs or millions and billions of shellfish. I mean, how are you going to fossilize all that rapidly?
All right.
Right.
Yeah.
Okay. I was hoping you had run into some evolutionist that, explained it to you like it's something simple, but apparently you haven't yet. So hopefully you will.
Yet. That's the key word, yet.
Okay. What is that guy's name?
All right. Well, let's get into Robert, were you saying something?
Yeah. No, I was trying to remember the guy's name.
Oh, okay. All right.
Yeah. He's a very famous evolutionist, like on the scale of Stephen Gould, but I just can't remember his name right now. I think it starts with a G. I may remember it I don't know.
Okay. All right. Well, if you guys want to, and seems like a pretty good place to switch over and, back into some of the cosmology questions.
Good.
And I think that this is a good question to start with too. Is the Earth 93 million miles from the sun? And if we are in a geocentric model, why doesn't the sun and its gravitational force suck the Earth? Have that gravitational force to where obviously the Earth would not be in the center. And what I wanted to do also, Robert, is just highlight exactly why the geocentric model, like how it does actually work with the Earth functioning as the center of mass. And
yeah. So even Newton understood that if there was a force that could counterbalance the sun that was outside the solar system, you could have the Earth in the center of the system with the sun going around it. Even Newton admitted that, and we know that from the Principia Mathematica, the last page of the Principia Mathematica, page 510, that was lost, quote quote, lost for 350 years until George E. Smith from Tufts University found it and wrote a paper on it that he sent to me, where Newton says this. He says, okay, look, if you have just the Earth and the sun, of course the Earth has to go around the sun because the sun is a mass of ice, it's a million times bigger than the Earth. So the gravity is going to pull. The only way the Earth can escape is by some velocity sufficient enough to keep it away from the sun, obviously. Okay. So that theory reigned for 200 years. And it was much better than Galileo's, because Galileo had no proof. He had no science. He had no equations. But Newton comes along with an equation that he can put on his theory and say, this is why the theory works, because of this math equation, F equals ma. Okay, so the force of gravity of the sun, which is the F, against the mass of the Earth, which is the m, has to have an a acceleration that compensates to keep the Earth away from the sun. All right, yeah, that all makes sense. Here's the problem, though. You can't arbitrarily ignore the rest of the universe and say that the universe is inert, absolute, not able to move, and is basically infinite. And the reason he has to have an infinite is because he can't have the gravity of all the celestial bodies collapse in on one another, because then we'll just end up with a big ball. So he doesn't want to go that direction. So he has to make the universe infinite. If you make it infinite, it can't move. If it can't move, it's inert. And so it has really no effect on our solar system at all. And so that was the reigning paradigm for 200 years. And then this guy comes along, German guy named Ernst Mach, and he says, look, physics deals with empirical evidence, and you cannot put a metaphysical assumption into your theory that basically runs your theory and allows you to make these conclusions about what has to go around what. You have to accept the fact that the universe. You okay?
Yeah, I got a baby that's fighting with my other child. Sorry.
Oh, okay. Do you want we can terminate and come back some other time if you want.
You just continue for like 2 minutes and I'll be right back.
Okay. All right. So that's the first puncture into the Newtonian dynasty, because it was a dynasty. Even Immanuel Kant said Newton was the king of science. If you got the endorsement of Immanuel Kant in the Enlightenment period, you're sailing, buddy. It was all wrapped up, and all these forces are coming against the church at this time, saying, give it up, Catholic Church. Stop clinging to your stupid tradition. We've got the equations. You can't beat the equations, So it looked like the church was going to sink in the midst of the Newtonian sea, right? So Mach comes along and says, look, here's the basic flaw of your system, Newton. You cannot assume things to be true that you can't prove. Yeah. And that one, the basic one is you can't prove that the universe is inert and not moving. Because let's say I make the universe move. In other words, let's say I make it rotate. Then what happens? Well, here's what happens. He wrote a whole book of it called The Science of Mechanics in 1888.
This is Ernst Mach.
Yeah, Ernst Mach. So he told us what would happen. He says, basically, there's no difference between what you see with the Earth rotating in a fixed universe as opposed to a universe rotating around a fixed Earth, dynamically and geometrically. Okay, not just geometrically, because that's what Galileo and Copernicus were doing. They were just working with geometrics. They didn't know anything about dynamics. But Newton put dynamics into the mix, and Ernst Mach then used dynamics and said, well, here's what would happen. There would be no difference. And then Einstein came along and basically endorsed what Mach said, and it became known as Mach's principle. So that's why you can have a geocentric system. Newton has to be knocked out of the way. He has to be knocked out of the way by saying he has no proof to his absolute fixed universe.
So if I can just interject with a question. Yeah. So Mach's principle basically is that you cannot absolutely tell the difference between geocentric and heliocentric based on observations alone.
Well, he also has dynamics in there. And then the dynamics were actually worked on by other people, starting with Einstein's general relativity. Because Einstein's general relativity is based on dynamics. In other words, Einstein says that you can have gravity and the warping of space and all this. That's dynamics. Okay. But if you have a dynamic system that supports the heliocentric system, you also have to have a dynamic system that supports the geocentric system, which is demanded by general relativity, because it is what? It's relative, you see.
Didn't
So
even
everybody was finding out that it's not just geometry that we're talking about. We're talking about dynamics here. So we've had many scientists, Hans Thierry in 1915, Joseph Lenz, Christian Muller, the guy that named the Big Bang, Fred Hoyle.
Nature.
No, this was different. Fred Hoyle.
Okay.
Julian Barber, who was in our movie, The Principal, and many others. I have about 24 of them who have worked out the mathematics in general relativity to give us a geocentric system, okay? Dynamically speaking, not just geometrically speaking, which makes all the difference in the world because nobody can disagree with it now.
Yep.
Our best math, our best physics supports a geocentric system. And that's how you get Newton out of the way. You say, no, you can't have your absolute system. And the reason Newton needed an absolute universe was because in his concept of inertia, a body that's moving has inertia, so it's going to keep on moving unless compelled upon by what they call a net external force. So unless there's another force that's going to hit that moving body, it's going to move in a straight line. But here's the trick. How do you define a straight line? Okay, what if the space that the object is moving is curved? What if it's not straight? Okay, then what do you have? Well, you don't have a body moving in a straight line.
Right.
You have it moving in a curved line. And that's where Einstein's relativity came along, because space is now curved instead of straight. You see, two different concepts. So, but that's why he needed his absolute universe, because he had to have a background that didn't move so that the object moving through it would move straight. That's the only way you can measure it, is moving straight if the background didn't move, you see. So once you get rid of that idea and call that an assumption that can't be proven, the whole thing's wide open now. It's all wide open. And that's why we can have the resurrection of geocentrism based on dynamics, you see, which makes all the difference, as I said.
Yeah, and that's wonderful. And a lot of people I run into is they really do believe that the Newtonian system is still like the best system, and most people are still coming from that reference. You know, especially folks around your guys' age that I speak to. They have no idea what they're running into whenever I present Einstein and Newton and all the modern
even if
scientists
Einstein isn't right. Even if Einstein isn't right in his general relativity or special relativity, the concept that he gave us that fights against Newton is sufficient in itself. And as a matter of fact, Einstein said, if Newton doesn't allow the universe to rotate, then that shows the defect in his system.
Yes.
Einstein said that. Okay. So we have a whole new world.
Yeah, it's just wonderful. It's
Thanks
awesome.
Be to God. Thanks
be to God. And you know, if you watch the history of the geocentric movement from, say, the church dealing with Galileo through the 1800s, 1900s, at every point where it looked like modern science was going to prove that the earth was going around the sun, God gave us men who did experiments to show that it wasn't true.
Yes,
the
miraculous preservation of geocentrism is just so wonderful to see throughout history.
Like when you see George Bedell Airy did his experiments with the telescopes, the water-filled telescope and the air-filled telescope. That came right at the right time, because it was almost as if the heliocentrists were going to win the war. Yeah. And then his experiment came. And then right after him, we had Michelson Morley come in 1887.
Right.
You know, where it like just blew everything wide open. And as a matter of fact, the scientists of that day were saying, look, one of the only ways we can explain this is by saying that the earth isn't moving. The most famous physics experiment in the history of the world, these guys were saying that one viable explanation is that the earth isn't moving.
Yeah.
Okay. And the only way they could get out of that was by Einstein coming along, and they scratched their head for 25 years on this experiment. Einstein came along and said, okay, look, the only way we're going to get out of this is if we say that the length of the interferometer arm contracted.
Yep.
And we have to assume the Earth is moving. So if the Earth is moving, the Earth contracts, the interferometer arm contracts, this room contracts, everything contracts by a secret formula we have,
right,
called the length equals the new length times the square root of 1 minus v squared over c squared. That's called the Lorentz contraction.
Yeah.
And every object in the world has to go through the Lorentz contraction so that these guys can have an answer to the Michelson-Morley experiment to keep the Earth moving.
Well, and think about how convoluted that is. You look at, when you're looking at data in science and you want to give an explanation for the data, and you think about spending 25 years to come up with this theory, and there's no empirical proof whatsoever. You have to ad hoc a theory in order to explain a very simple observation.
Yeah. Well, here's what happened with that. It was Henrik Lorentz in 1892 that figured this out. Well, actually, before him was George Fitzgerald from Ireland, and he proposed that the way you answer Michelson-Morley was by saying that the interferometer arm contracted. But he told Lorentz, he goes, they're laughing at me over here in Ireland, that I would think up such an ad hoc theory to explain this simple experiment. He goes, but now that you've come along, and Mr. Lorentz, because he was a world-class physicist, Lorentz, now that you've come along, they're not laughing at me anymore. They're taking it seriously. And so Lorentz's theory was that as the interferometer arm in the Earth and everything else went through the ether was putting pressure on the interferometer arm, so it contracted a little bit, you see? But Einstein didn't like that answer because that made space absolute, because now it had ether. So you get rid of the ether and you say that the length contraction occurs because that's just nature. Nature that's the way it's made. And that was his explanation.
Well, and that's what I wanted to get into next. And sorry, I wasn't trying to interrupt you. I was just trying to correlate this with the next experiment and how Einstein, concocted special relativity in order to answer that experiment.
Yeah.
But then later had to contradict special relativity with general relativity due to the light speed and the initial expansion and whatnot else. But if you could further explain how he had to go into general relativity, and basically that explanation for Michelson-Morley from special relativity is actually not an explanation at all.
Yeah. I mean, special relativity, as you just said yourself, that was the way out of the Michelson-Morley.
I'm on Irma.
And so if you say that light speed is constant, that means you have to take out everything that could make it non-constant. Whether it's ether, schmether, you can call it anything you want. Magnetism, electricity, air pressure, water, whatever it is, it can't be there. Special relativity has to work on presuming that the environment that the light beam travels is pristine. Okay? Now, here's the question. Where are you going to find a place in the universe where the light beam can travel in a pristine environment, unaffected by any kind of force, medium, whatever it is? Where are you going to find that? Nowhere.
Yeah.
The whole universe is made of gravity and everything else. So the special relativity theory, although it helped theoretically to explain Michelson-Morley for them, it didn't work practically. It couldn't fit anywhere because of all its limitations of this need for a pristine environment.
Well, I mean, if I can jump in here, me, ordinary guy looking at this, I remember being taught about the twin paradox because that uses the Lorentz contraction. Where basically, I'm 62, Levi, how old are you? 30 something?
37.
Well, let's just say you're 32, just for math purposes.
Okay.
So according to that, if I take a ship at the speed of light to a star 15 light years away and then turn around and come back, I'm going to be a couple of weeks older. Levi's going to be my age at that point. But then who's to say, am I the one moving or is he in planet Earth moving?
Yeah,
So
exactly.
maybe he should be the one that's you know, I'm 90 when he comes back, and he's still 32 or 37. So
Yeah.
yeah, that's so with the interferometer arm contracting, I mean, who's to say it wasn't the sun that's contracting? You know, going
Yeah.
around the Earth. I mean, because you
Yeah.
could go either way with that. So yeah, I just wanted to chime in with that.
Yeah.
Well,
Yeah.
have
Good
you
job.
guys seen
Good
that
job.
movie with Jodie Foster back in the day? I cannot remember the name of it, but it's where they go to space and basically,
Contact.
yes, Contact. That reminds me so much of that because of the time and all that. She comes back
Yeah.
and everyone's older and she's older, and yeah, it's strange.
Well, see, and here's the other problem with special relativity. I just gave you the pristine environment problem. Here's the other problem. If you claim for whatever reason that interferometer arm is contracting, here's what the problem you're going to get into. That means that the interferometer arm is not as long as it was before. So when it goes from point A to point B, guess what? It's not going to get there in the same time because it's not as long as it was. Okay. So then what do you have to do? Then you have to dilate the time. You have to increase the time that it travels so that it does get to point B when you expected it to get there. And that's where this whole idea of time dilation comes from that you see in Star Trek. You see? Because if I can manipulate the length, I can manipulate the time. There's no difference now. And that's why it's called space-time, because time is involved now, because time can be manipulated. Okay? This is what we left back with in Newton. At least Newton had an absolute time. The only problem was he had an absolute space that he couldn't prove. But at least he had an absolute time. With Einstein, time is malleable now, you see. And it's got to be malleable because we have to make the experiment work. We can't come to the public without an explanation. And here it is. We manipulate the length, the time, and we also manipulate the mass, by the way. Right. Because you're not going to have the same volume per cubic centimeter as you would normally. So the mass has to increase because the volume is smaller. Okay. And so those are the three cardinal virtues of special relativity: length, time, and mass manipulation. That's the kind of world these guys live in. Yeah. Okay. I mean, so then, that only works in a pristine environment, as I said. So when you come to the real world, where you have gravity, mediums, inertial forces, all kinds of things that are in the universe. Well, now what do you have to do? Well, light is going to be manipulated by all of them. So we can't say that light's constant anymore in general relativity. You see, light can be affected by the environment. And that's what relativity basically does, because the biggest thing out there that's going to affect light speed is gravity. Gravity's everywhere. It has to be, because we see all these masses out there. We know the sun has gravity, Earth has gravity. They must have gravity too. So there's no place you can shoot a light beam where you don't have gravity, you see. So you have to deal with the real world now. And then Einstein takes the ether back. The very ether that he got rid of in the Michelson-Morley experiment to keep light speed constant, he takes it back in the general theory of relativity, except with one provision. We're not going to claim anything physical about it. We're going to claim that it acts physically, but we're not going to claim what it is.
Right.
So that's where you get this whole idea of metrics with Einstein. It's just a metric quality, but we're not going to explain to you what the quality of it is physically.
Well, I mean, jumping in here regarding the ether, I mean, metaphysically, if there were nothing between absolutely zero between mom and me, I would be right next to her. That would be true
exactly.
Exactly.
So there has to be a something there.
There's something.
Even though we might not know
something,
what it is.
Yes.
Yeah. So
well, and can we jump into, while we're right here, this is important because it just is. The waters above the firmament. How do we explain that from the geocentric system?
Well, here's how I explain it. And we do so in our video series, How the World Was Made in 6 Days.
And it's wonderful. If anybody hasn't seen that, please go and check that out. It's beautifully done. Wonderful, wonderful content.
And you have to know a little Hebrew, which I'm going to teach you right now, and you'll see how important it is. In the first verse of Genesis 1, it says, in the beginning, God created the heavens and the earth. Okay. And then it says, and then you have your Vav disjunctive, by the way. and then it says, and the earth was without form and void, and darkness was upon the face of the deep. So you have the deep mentioned, but it didn't say that the deep was created. The water was created. It just says in the beginning, God made the heavens and the earth. The earth is assumed to be existing, and then it says, and the earth was without form and void. But then it says, and darkness was upon the face of the deep. Well, where did the deep come from? Okay, so we have water existing on the earth, above the earth. The earth is the earth. Anything above it is above it. The water is above it. Where did this water come from? Okay, well, my proposal is this, that the heavens are the water. Okay, and it just so happens that in Hebrew, the word for water is mayim, and the word for heavens is shamayim, which means what? From water.
From water, yes.
From water. Okay, so the heavens at that time was the water that's surrounding the earth. Okay, and then it's a matter of what's going to happen to that water, and that's when the second day occurs, when the firmament is created. And what does the firmament do? And I go into how the firmament is created and what it is, okay? But it's a solid substance that divides the water so that there's a little bit left on Earth and 99% of it's above the firmament. And then the firmament, because the other scriptures say that the firmament or the heavens are stretched.
Yeah.
Okay. There are 10 verses that all say that the heavens are stretched. Okay, so that means the firmament, which is called the heavens in verse 8, that's stretched. And when it's stretched, what happens? It takes the water with it.
Yes.
All this water goes out, and a little bit of the water is left on Earth.
Yeah, it's not a Big Bang expansion. It's actually the firmament spreading into the outer space.
Yeah, and we can give the dynamic reason why that firmament is stretching. I mean, you could say, yeah, God, snapped his fingers and made the firmament stretch. But there's a reason, chemically speaking, why that water stretches, which I'm not going to get into right now. But anyway, so we know the firmament stretching out the water to the rest of the heavens, okay? And that's why we see so much water out in the heavens. Everywhere we look today, we see water.
Yeah, that's what I was going to ask you to kind of delve a little deeper into is how they have found water molecules. They're different than our solid water here, but how there is water all throughout space. It's just in a different form.
Yeah. And we know the three forms are, ice, liquid, and steam. Can appear in any one of those forms, and sometimes in all those forms. And we have water today that they've discovered. I've read all about water. It's amazing.
Yeah, that's what I wanted you to touch on. Yeah,
we've had, where you have the typical V, where you have two hydrogen atoms coming from the oxygen in a V shaped. Okay, and that's what creates normal water. And then they have water that they've had where the oxygen is in the middle and you got two hydrogen atoms on the side. Okay, and they have found that water can start to boil at 2100 degrees centigrade.
Wow.
Yeah, I mean, it's amazing the difference in the molecular structure that water will sustain and be stable and perform all kinds of different things that we never even thought of before. Okay. But as far as, they found water in the sun, in the stars, on the planets. Pluto is all ice. The whole planet is ice. Uranus, the whole thing is ice. So is Neptune. This is real water.
Yes.
Where's it coming from? Okay. Well, now we know, because this water is being spread out everywhere. They found water in quasars, all kinds of things that are out there. All of them have water. you know. Now, what's the first thing the evolutionist is going to say? Oh, well, see, water, that means there must be life out there, you know, and yeah,
Yeah.
that's what they do with it. But what we do is we back up what the Genesis record is saying, because the whole thing from the get-go was based on water, the deep. And how deep would that be? Well, it would be billions of miles deep, because that's how much water we see out in the universe. This is my theory, that water is the basic structure of all life, not carbon. Carbon is a close second, but water, the hydrogen molecule, is like the basis of all life, and that's why we see so much of it everywhere. So that's how we would. That's how.
In my next interview with you, Robert, I want to talk about your book. You know, the Googleplex book, and I'll show everybody it real quick. Googleplex of tiny black holes. If it, well, it ain't gonna show up on the screen, I don't think.
You know, your picture on your screen is like popping in and out. It's almost like in another dimension or something.
It's kind of weird, isn't it? Yeah, I don't know if I'll do the background thing anymore, but I knew my kids were going to be stinkers, so I wanted to avoid all the chaos in the background, because I knew I was going to be chaos.
Okay.
I'm going to have to step aside for 30 seconds. I have to get a charger because my phone.
Well, and Adamar, I'm basically, when you get back, I'm kind of wanting to do closing statements with you guys and just kind of end the conversation. I got my two kids here.
Let me get my charger so the phone.
Excellent. Yeah, Robert, I want to interview on this about your theory of gravity and all that. Yeah, I think it's very, very brilliant and mind-opening, and I love how the firmament with the water and Shamayim and how it all correlates so beautifully, because, you know, the firmament at first, it's this solid substance that's kind of this separating barrier, but then as it spreads out, you know, it becomes this, you know, obvious, you know, we can put our hands and our bodies through the air without smacking into a hard substance, and same thing goes on in space, but yet that is still the firmament.
Yeah, you know, and the thing that intrigued me the most was what element that God created could best serve that dual purpose of being solid on the one hand and yet ethereal on the other.
Yes.
In another state. And there was really only one element that fit the bill, and that was hydrogen. Yeah. Because hydrogen at low temperatures is a metallic solid. It's a black metal. Yeah. And it's hard, right? Okay, so they could hold back the water.
What a great
that same hydrogen, when it's heated up, which would be heated up by the light that God created on the first day, once it's heated up, man, it turns into a dispersed gas that once it's out there, you know, and we, you know what the element we see most of in the universe? 90% of it is hydrogen. Hydrogen. Where did that come from?
Yes.
Okay, now we know it was this big, massive hydrogen thing that the firmament was at one time, and that matches the Hebrew language, because
what element is most essential to life?
Yeah, hydrogen.
Water and hydrogen.
Yeah, and then it matches the Hebrew, because the Hebrew rakia, which is the word firmament, on the one hand, it's depicted as a hard metal in Scripture, and on the other hand, it's what
it's that spread out.
In verse 14, the heavens are called the firmament.
Yes.
Okay. Well, that's something ethereal. That's not something solid.
Yeah.
Talk about science and theology, man. I mean, we get called anti-science and pseudoscience, and it's like, or just against science, period. And it's like, if you really delve deeply into the creation theology of traditional Catholic creation, it couldn't get more scientific and more theological.
Here's the thing, though, is you have to believe it first. You have to believe that what God wrote in Genesis 1 is not story filler.
Yes.
It is actual scientific history. And unless you come to that conviction, you can spend all the time you want in Genesis 1, and you're never going to get to these conclusions that we've got.
Well, I would say the problem here is a lot of people practice what I call temporal snobbery. they assume that we are more advanced than the so-called primitive people that God supposedly dictated mythologically to because they couldn't understand the truth.
Yeah, exactly
And
right.
so somehow all these people in the time of Genesis were very just primitive, essentially troglodytes. When in reality they knew more than we do, and they were more sophisticated. It just just because you don't have a cell phone 3,000 years ago doesn't mean that you're more primitive than somebody living now.
Yeah,
So,
that's
anyway.
exactly right. Snobbery. So, at any rate, what else do you want to cover?
Yeah.
Did I think I covered rakia? Yeah, the two definitions in Hebrew of rakia. So, yeah, that fits. Anyway, there you go.
Yeah. Well, I'm needing to close this one up just for now, and I wanted to just let you guys have some final statements that you guys want to make before we cut loose.
Adamar, go ahead.
All I would say is I want to encourage the audience, no matter what your credentials are, what your level of education or whatever, remember you're given an intellect by God, and no credentialing, no none of that stuff is worth, as we say in Ukrainian, a pound of lint, unless you can present the facts to back up your claim.
Yes.
So you need the data set, and a child can come up with a data set just as well as a PhD adult, or somebody with 30 PhDs, or somebody who's a cardinal. It doesn't matter, as long as you're able to present the data set and then a reasonable explanation for what you see.
Yes.
Or to explain why you have that data set coming together. So that's, I would say, I would encourage people, think outside the box, question narratives, and remember, God doesn't lie, so scripture is literally true, but and the magisterial teaching, obviously, that's consistent from the beginning. But the main thing is think on your own, and think this stuff through, and hopefully a next episode we might be able to do the electric universe. That's a huge rabbit hole, but that's worth exploring too. Okay. But anyway, so I'm done. Thanks for listening, everyone.
Robert, you got anything you want to close with?
Yeah, the thing I always close with is, and I just mentioned it prior to this closing, which is, you have to believe that scripture is written by the infinite mind of God, who, as Adamar said, does not lie. If God does not lie, that means nothing he says has the slightest doubt about it. And unless you come to that conviction, don't even bother reading scripture. And I mean that. I mean that.
Yeah.
Especially if you're going to start applying science to scripture. If you don't know what scripture's saying and don't believe it because it's written by primitive men who didn't know what they were saying, don't bother. We have too many people doing that today with theistic evolution and all this kind of stuff. They think they know what they're talking about because science told them. Science has been overturned. I don't know. Probably was like George Kuhn, who wrote the book Scientific Revolutions. Science has a revolution every 50 years or so because everything they thought they believed is wrong.
Yep.
And then 50 years from now, everything they think they believe now is going to be wrong. You see. So
yes,
it's like, why do you guys depend on this shifting sand beneath you? And here you have the God of the universe who does not lie and tells you he's not going to give you facts that have no meaning or just story filler. But you have to have that conviction. Yeah. And that only comes from the Spirit. And very few men have it. Unfortunately, it is a crime, a sadness that I just can't get over, of how little men really trust in God and his word. They all give lip service to it, but really, really trust it.
Well,
that's where you have to start. That's my final word.
Thank you.
Oh, could we close with a prayer then?
Oh yeah, absolutely. And just one point that I wanted to make before we do, it goes along with what Robert was just speaking about. I always tell people, when you're trying to read scripture and impose a big bang onto it, that, that's not the proper way to read scripture. And you would never, ever go through scripture, and even going through the original languages and doing research on that scripture, you would never, ever, from the scripture alone, ever glean a big bang or billions of years from the Holy Scriptures, ever.
Yeah.
So,
well, I think God wrote Genesis precisely that way. He made the earth first, and in the Big Bang, when does the earth come? 8 billion years after the Big Bang, 4 billion years after the stars. But God made the stars come after the earth.
yes.
So right there, you just have a totally upside down paradigm.
Yeah.
And how are you going to fit the Big Bang in that? Huh? Now, I think God wrote the Bible precisely that way.
Well, and the convolutions that you hear from people when they do try to do the exegesis it makes me laugh.
Oh yeah. Like Hugh Ross.
It's so outlandish.
Hugh Ross is one of those guys.
Oh, it's awful.
Yeah. Anyways,
let's pray. I love you guys. God bless. Let's pray.
Likewise.
Do you want to? Whoever wants to lead?
Adam Mark, go ahead. Adam Mark, give us a good prayer.
Thank you, brother.
Okay. Well, I'm going to commend this to the Blessed Mother in thanksgiving. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Hail Mary, full of grace, the Lord is with thee. Blessed art thou among women, and blessed is the fruit of thy womb, Jesus.
Holy Mary, Mother of God, pray for us sinners now at the hour of our death. Amen.
Yeah. Amen. And our Mother, perpetual help, aid
Pray
us and protect our efforts in all these endeavors that we're doing to defend the truth of Genesis.
Amen.
Yes, pray for
Amen.
us. Amen.
Father, Son,
All right.
Holy Spirit.
Thank you, guys. Nice to be with you.
Thank you.
Hey, God bless you. Yep. God bless you guys. You guys rock.
I'm going to end this stream.
All righty.